This is the dry fogger fuel atomizer system. This system uses micro orifice impaction pin nozzles, or dry foggers, that produce 0.5 to 0.25 micron droplet sizes. They're generally used for control of odors and to humidify or mist patios or things of that nature. This system uses one or two orifices fixed above a carburetor, butterfly, or throttle body. You could even have a type of slide or something in place. My plan is to modify a 2-barrel or a 4-barrel carburetor, strip it down, and just use the bottom butterfly plate and the body of it to allow the mixture to pass through into the heads. Mine is going to be set up for a Ford 302 or 351 Windsor that uses the old school eccentric pump drive. They look like this. This pump is going to be used to drive a CDI unit that will pump up to 2,000 or 3,000 PSI if necessary. Reinforcements may need to be made on this rod. This system here will use this pump and this micro orifice impaction pin nozzle to produce a fog, or a maximum atomized solution, so that an internal combustion engine will be as efficient as it possibly can be, which means little to no emissions and maximum fuel efficiency. This system will take us from miles per gallon to gallons per hour. This system should use between 0.2 and 1.5 gallons per hour, no matter how much distance is traveled. This system uses the cam-driven CDI pump. That kind of pump uses a solenoid to allow a certain amount of fuel in during the compression stroke. This will all have to be timed to the plunger. This plunger and everything else will compress at a certain time every time the engine turns over. This will have to be signaled by a wire that runs to the pump that allows a certain amount of time for this to be open, which allows you to control your volume and pressure on your fuel line. The signal wire will come from a reed switch. This is going to be a very simple mechanical version that I'm going to build. The reed switch will have wedges affixed upon the harmonic balancer. Those wedges will be in the exact place that this pump begins to stroke up. The wedges will be placed in the compression stroke of the pump. The reed switch itself will slide back and forth on a spring-loaded slide that's controlled by a throttle cable. Very simple. If I throttle up, the reed switch slides back to the wide part of the wedge, which allows it to send a longer signal to the wire, which allows the pump to suck in more fuel and create more pressure and volume. If I'm idling, it will be at the beginning of the wedge, which will allow a small amount of metal to pass by, allowing less signal to the pump, sucking in less fuel and creating less volume. This is how I'm going to control it. There are probably hundreds of ways to control the opening and closing of that little signal, the little solenoid. Possible orifice sizes are here. I need to figure out what size droplets I can expect from these different orifice sizes. Those are in millimeters and thousandths of an inch. And I guess I'm probably leaving some things out, but this is the basic idea of it. If we can set this up, we might need to figure out a way to have a second orifice kick in at half throttle to full throttle. I think we might need more volume when the engine is sucking more air and fuel mixture. That can be controlled with the throttle as well, or maybe vacuum advanced system, or an electronic system that just senses the throttle being at 50% or more, which would be like a throttle position sensor, to open up a second orifice. There's probably more revisions that will come, but this is the basic of it, or the basic idea of it. I hope maybe this helps somebody.